Welcome back everyone. In yesterday's video, we had just started with Charpit's method and we solved an example. In today's video, we'll solve another example using Charpit's method. Okay? But here, I have taken a bit different example where you will have to substitute something from this particular given example to get a solution easily using Charpit's method. Otherwise, it will be very lengthy. I'll show you how. See, let us say we are given this particular equation to solve. And we are asked to solve this partial differential equation like we did yesterday. See, if we write f of this particular given PD, mm, what will we write as? See, this as it is here means just I have taken this part to LHS. You will say how did I write P here? Dou z by dou x is P. Dou z by dou y is Q. Okay, so this as it is 2x into z square Q square plus 1. This term is here minus this ZP. Now once we have F, if we find fx, fy, fz, fp, fq, like we did earlier, fx was dou f by dou x, dou f by dou y, dou f by dou z. Similarly, dou f by dou p and dou f by dou q of this particular equation. We will get these terms. Okay. See, once we get this, and now if we put in yesterday's Charpit's equation, what was it? It was dx upon what was it? I guess fp plus it was sorry equals to dy upon fq equals to what was it dz upon pfp plus qfq plus sorry again equals to it was dp upon fx plus it was whole minus fx plus pfz equals to dq upon minus of fy plus qfz. Okay, now one sec, you are saying we don't remember it. See, this was it. Okay, we will have to put those values here of what fp fq p into fp fq these values. Once you put, so this is what you will get here dx upon this is our fp. Like yesterday I told, if you multiply this throughout by minus, there won't be a issue. So this minus z becomes plus z. Similarly, it was dy by fq this term. So we have multiplied by minus, so we are getting here minus again dz by pfp plus q of q and so on. But what I wanted to tell you is that see, if you look here, how will you rearrange this? What substitution you will put? It gets very difficult to solve in exam. Okay, because you have limited time, and that is the reason we will have to use some substitution so that we get at the answer earliest and save our time. So whenever we have such problems, if you see this particular term, just observe it, and this particular term. Here we have z into dou z by dou x. Here we have z square into dou z by dou y square. Can I write this particular term as z dou z by dou y whole square? Similarly, it can be written as then z into dou z by dou y whole square, this part, and similarly this part I'll write here z into dou z by dou x. From here, what we can say that we can put this particular term z dou z equal to something. Okay, so that is what I have done here. I have said like z dou z be some dz by 2. Okay, if I take something like this and integrate on both sides, what shall I get? I'll get as z square by 2 equal to some capital Z. Okay, by 2. This 2 gets cancelled and I get z square equals to some capital Z. This is small z. So I substituted z square equals to capital Z. From there I get 2z dz equals to this capital dz. Now substitute this back in the given equation, which was this particular thing. What shall we get? 2x into. Here, this term was z into dz by dy whole square, right? And here we substituted this dz by dy, sorry, z dz by this dz by 2. Okay, that is the reason we have here this dz by 2 and this dy plus 1 whole square. Similarly, here minus 1 by 2 dz by dx. Once we have these values, just rearrange this. And on rearranging, this is what we get. Okay, here I have written capital Q and capital P. The reason being, you will have to substitute back z here. See, small p is our dou z by dou x, correct? So when you substitute something for capital dou z by dou x, we thought it of some capital P. Okay, these two p's are different. That is the reason we have substituted capital P and capital Q. Now once we have this, now say this is some f of x comma y comma z comma p comma q. Okay, like this. Now get fx, fy, fz, fp and fq by taking its partial derivatives and then substitute it in Charpit's equation. Once we substitute here, see this one directly we can substitute or see, this is 0, equate this to 0. Equate, integrate, we get q equals to a. Okay. Similarly, here a is a variable, okay? Or we can say constant, where a is a constant. Now, once we have this a, we will put a in, let us say we put a here. What we get is that ax square plus 4x minus p equals to 0. From here we get p equal to a square plus x, a square plus 4 into x. Now see, I had told you earlier that our mid goal is to find q and p. Once we have these two, then we will integrate this. Dz equal to p dx plus q dy. Because see this p and q, if I directly put it here, where did it go? In this equation, in this equation. I guess still it should be okay. But let us see how we get, what we get here. Here we will be getting a general equation. So dz equals to p into dx plus q into dy. This was our p, this is our q. Integrating dz we get z. Here we get integration x square by 2 and here ay and some constant b. Now this particular z is our capital Z. But our actual answer we will get when we replace this capital Z with small z, no? Which was z square. So replacing it back, we get z square equals to a square plus 4 into x square by 2 plus ay plus b. This is our final answer, where b is another constant. Okay, thank you.